Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmotol, Kathmandu, and Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 9, this is your science class, and in your science class we have been studying about lesson light, isn't it? And this is your third class on the lesson light. Well, up to our previous class we discussed about refraction of light, cause of refraction, and laws of refraction. Yes, and we also studied about refractive index. Okay, if you have in case forgotten those lessons, then you can always replay the video. Okay, well, today we are going to discuss about the effects of refraction of light. Well, have you ever noticed some of those things, like a pond, when you look into it, it appears to be shallower. This one we have discussed in our previous class as well. Okay, a pond appears shallower than its actual depth. In a swimming pool also, तिमीहरु स्विमिङ पुल गएको हुन्छ, स्विमिङ पुलमा यसो हेर्छौ, हेर्दाखेरि 4 फुट जस्तो लाग्छ है, तर त्यहाँ हाम फाल्यो भने खुट्टाले भुइँमा छोइँदैन, डुबिन्छ. एक्चुअली त्यो चाहिँ 6 फिटको भइरहेको हुन्छ. हैन, किन हुन्छ त? 6 फिटको छ तर किन 6 फिट देखिएन? 4 फिट मात्रै किन देखियो त? है, एउटा यो इफेक्ट भयो. अनि त्यसै अर्को इफेक्ट यो पनि भनेको थिए कि पेन्सिललाई या कुनै एउटा लट्ठीलाई पानीमा सिधा डुबायो भने के हुन्छ, त्यो पेन्सिल या लिटु लट्ठी चाहिँ छोटो देखिन्छ है. छड्के डुबायो भने त्यो बाङ्गो देखिन्छ है. यो गरेर हेरेको छौ कि छैनौ? ओके, let me see if I can find anything. Okay, I got it. Look at this picture. This picture shows a straw. Yes, when you look directly into the water from above, you can see that at some angle you can see that the straw is bent at the surface of water. But if you directly look through the glass of water from the sidewise, then you can see the straw is somewhat appears to be thick, isn't it? Both of them are just a virtual appearance. Okay, seems like this, but it is not like this. Okay, so why does it occur? Why does a straw seems to be bent at the surface of water? Okay, why does it happen? Yes, that is another effect of refraction of light. Okay, the second one, say a stick dipped in water seems to be bent. And third one, when a person spears a fish where it seems to be the javelin never eats the fish. If you are inexperienced fisherman, okay, if you are inexperienced fisherman and you have to fish, you have to kill a fish, catch a fish by throwing a javelin, then don't throw where the fish seems to be. Okay, don't throw where the fish seems to be, and because the fish is not there. The माछा जहाँ देखिन्छ त्यहाँ हुँदैन. तिमीले जहाँ देख्यो त्यहाँ javelin हान्यौ भने, javelin भनेको भाला है, त्यहाँ javelin हान्यौ भने त्यो javelinले फिशलाई लाग्दैन. Okay, so experienced fishermen, they have to calculate the distance. Okay, actually fish कहाँ छ हैन, र त्यो fish कहाँ देखिन्छ, apparent spot र रियल स्पट बीचको जुन डिफरेन्स हुन्छ, त्यो डिफरेन्स केले सिकाउँछ त तिमीलाई? एक्सपिरियन्सले सिकाउँछ. ओके, एक्सपिरियन्स फिशरम्यानहरूले चाहिँ त्यही डिफरेन्स गेस गरेर चाहिँ ज्याभलिन थ्रो गर्ने गर्छन्. ओके, बट इफ यु आर इनएक्सपिरियन्स, इफ यु आर न्यू फिशरम्यान, देन obviously you would throw the javelin where the fish seems to be. जो दिखता है वो होता नहीं, जो होता है वो दिखता नहीं भनिन्छ नि है, भनिन्छ है. यहाँ त्यस्तै हुन्छ के, माछा जहाँ देखिन्छ त्यहाँ हुँदैन, जहाँ हुन्छ त्यहाँ देखिँदैन. अलिकति ट्विस्ट गर्ने अब यो पनाइलाई हैन त. ओके, सो द्याट इज अल्सो बिकज अफ रिफ्र्याक्सन अफ लाइट है. बुझिरहेको छ छैन? द फिश डज नट सिम to be its actual place. Okay, the fish does not appear where the fish is actually located. Okay, and next effect is, well, twinkle twinkle little star. You all know this rhyme, yes? How I wonder what you are. Now I'm going to tell you what you are. Okay, the star is a burning ball of hydrogen gas. The star, when the star is made at the beginning, it is 100% hydrogen. Okay, and due to very high pressure, the hydrogen starts to undergo nuclear fusion reaction and they produce heat and light energy. Okay, that light energy comes to earth. Now that explains what you are. Yes, what is a star? Now why does it twinkle? Why does it twinkle? Is the star really twinkling? Now actually the star is not twinkling. If you go to space or if you go to moon and look at the star, they do not twinkle. Okay, star twinkles only when you look at it from earth. Only when you look at it from earth, the star twinkles. Now that goes the answer to your question, why does it twinkle? Twinkle, twinkle, little star. Yes. Okay, actually the rhyme itself is misleading. The star is not little. When you see it from here, it is little, but the star is not little, it is huge. Okay, the star is billion times larger than our own earth. Okay, the smallest star is even a small star might be 4 times larger than our sun. Yes. Okay, so okay, anyway, just leave it. Okay, you understand my point. What my point is, stars appear to twinkle but actually they burn continuously, and this twinkling effect is also due to refraction of light. Okay, now today's class we are going to explain these 4 phenomena. Actually all of these 4 phenomena are similar to each other. Okay, let's go to our first reasoning. A pond appears shallower than its actual depth. Actually this is the question I gave you in your assignment as well. Yes, in our last class, in our previous class. Okay, see the reason. A pond appears shallower than its actual depth because of refraction of light. The light rays reflected from the bottom of the pond has to travel from water to air, that is denser medium to rarer medium. You can see that this is the bottom of pond. Yes, and the light ray coming from bottom of pond, let me zoom it. The light ray coming from bottom of pond, it has to travel from water to air, and you know that water is denser medium and air is rarer medium. So when light ray travels from denser medium to rarer medium, then it bends away from normal, that is angle of refraction would be greater than angle of incidence. Okay, so when this light ray is backtraced, then it appears to be coming from higher point. Yes, or upper point. Okay, in that way the point where it appears to be coming from, you will see the virtual bottom. Okay, you will see the bottom of pond at this place, whereas it actually is here, but you will not see the bottom of pond here. I told you na, जो दिखता है वो होता नहीं. Yeah, जो दिखता है वो होता नहीं, जो होता है वो दिखता नहीं. Okay, the thing which is there is not seem to be there, but where you see it, actually it is not there. That is what we call the virtual world, isn't it? Okay, you get it? I hope you got it. Okay, see, okay, up to here. Yes, so reflected rays bend away from normal, that is angle of refraction is greater than angle of incidence. Hence by backtracing the light rays, it appears to be coming from upper point. Actually it is coming from here. Yes, but it appears to be coming from here. Okay, any confusion? Okay, so let's go to next reasoning. A stick dipped in water seems to be bent. Look here. Okay, suppose this is not there. Yes, the stick, actual stick is this, but what you see there is this. When you dip the stick in water, you will see this. Okay, the stick appears to be bent at the surface of water. Okay, after bending at surface, then it again goes straight. Okay, you see this, but actually the stick is this. Here also once again the same thing. You do not see the reality. You do not see the reality, and what you see is not reality. Understood? Okay, and okay, see, this is the reality, but you do not see the reality. This is what you see, but okay, this is what you see, but this is not the reality. And this is such a riddling thing. Yes. Okay, now the reason is same. See, the words are almost same as the first reasoning. A stick appears to be bent when dipped in water because of refraction of light. Once again, here also the same reasoning is applicable. This is the tip of stick. Yes, from the tip of stick, actually light rays are coming from all the points on stick, but I'm going to consider only the tip. Okay, from the tip of stick, light rays are coming. Yes, and that light ray has to travel from water to air. The light rays reflected from the tip of stick has to travel from water to air, and water is denser medium, air is rarer medium, so the light ray has to travel from denser medium to rarer medium, and when it travels from denser rarer medium to rarer medium, it bends away from normal. That means its angle of refraction is greater than angle of incidence. In that case, if you backtrace this light ray, it appears to be coming from higher point. It appears to be coming from here. So this point of stick appears to be here. At this point, you will see the stick here. Got it? Okay. Any confusion up here? Any confusion? See, because of this, the stick appears to be bent. So the part of stick out of water is still there, but the part of stick inside water appears to be somewhere else. Okay, that's what caused it to be bent. But if you dip the stick completely in water, then it will not bend. Okay, it will bend only when it is partially dipped, and it appears to be bent at the surface of water. Now read the note. A stick appears to be bent when dipped in water because of refraction of light. The light rays reflected from the stick underwater has to travel from water to air, that is denser medium to rarer medium. So the reflected rays bent away from normal. Angle of refraction is greater than angle of incidence. Hence, by back tracing the light ray, it appears to be coming from upper point. Done? Any confusion? Okay, if there are no confusion in this question, then let's go to third question. Okay, say this. This is the most interesting one. Yes, you will see the fish here. You will see the fish here, but the fish is not here. The fish is here. The water acts as protective cover for here. Jal Devta, it seems like the god of water, Jal Devta, promised the fish to protect it by illusion. Right? जस्तो पुरानो कथाहरुमा सायद यसो भनेको लागि जल देवताले चाहिँ जीवहरुलाई आउ मेरो शरणमा आउ म तिमीहरुलाई प्रोटेक्ट गर्छु भनेन। अनि जीवहरुले कसरी प्रोटेक्ट गर्नुहुन्छ, पानीमा त मान्छेको भाला छिरिहाल्छ नि भन्दाखेरि जल देवताले चाहिँ के भने नि म माया या इल्युजन क्रिएट गर्छु ताकि चाहिँ मान्छेले जब तिमीहरुलाई हेर्छ तिमीहरु जहाँ छौ त्यहाँ देखिदैन, अन्तै देखिन्छौ। एक्चुअली त्यस्तै देखियो नि हैन र। माछा यहाँ छ, माछा यहाँ छ, तर कहाँ देखिन्छ? यहाँ देखिन्छ है। जो होता है वो दिखता नहीं, जो दिखता है वो होता नहीं, यहाँ पनि लाग्छ है। ओके, द रियालिटी, you cannot see the reality, and what you see is not the reality. Actually यो खासमा त्यो प्रभाव चाहिँ मान्छेको बिहेभियरको लागि भनेको हो हैन, मान्छेको कनिङ बिहेभियरको लागि भनेको हो, तर यो प्रभाव यहाँ पनि लाग्छ। इट इज भेरी it is very interesting. The reality does not seem to be, and what you can see is not reality. ल ओके यसलाई यसो गरौँ न, अझै राम्रो हुन्छ है. You can not see the reality, and what you can see is not the reality. ल interesting हुन्छ है. Just remember this. Okay, well, what is the reason of this? Let's see, let's analyze this. The light rays coming from fish, once again the light rays reflected by fish, they have to travel from water to air. Okay, they have to travel from water to air, and you know that water is denser medium and air is rarer medium. So when light ray have to travel from denser medium to rarer medium, the light rays bend away from normal. They bend away from normal, so that angle of refraction is greater than angle of incidence. In both cases you can see that. Yes, and the light rays, these two light rays, since the angle of incidence are different, then angle of refraction are also different. Okay, not in the same proportion, not in the same proportion, but their sign value will be in the same proportion. The angle themselves are not in the same proportion. Okay, so this light ray is bent more than this light ray. You can see that this light ray is bent more than this light ray. Okay, that is why these two light rays are divergent light rays. They form divergent beam and they never meet to each other. However, if you backtrace these light rays, then they appear to be coming from here. Both of these light rays appear to meet here. So you see the object, the fish, at this point. Image is formed at this point. Your brain will see the fish at this point, but the fish is not here. The fish is here. Understood? That's why. See? Okay, read the note. When a person spears a fish where it seems to be, the javelin never hits the fish because of refraction of light. The light rays reflected from the fish in the pond has to travel from water to air, that is denser medium to rarer medium. Yes, so reflected rays bent away from normal. That means angle of refraction is greater than angle of incidence. Hence, by backtracing the light ray, it appears to be coming from another point. So the fish seems at a spot, but actually it is not in that spot. Any confusion? Well, the diagram, they are very important. Okay, if these questions are asked to you, then the diagram is compulsory. You have to make the diagram whether you want or not, whether the question asks you to draw the diagram or not. You have to draw the diagram, because the diagram explains the phenomenon better than words. Okay, the diagram explains the phenomenon better than words. That's why even if you cannot write the words, write the answer in word, you have to give the diagram. You have to show the diagram. भन्छ नि है, तस्बिर आफै बोल्छ. ओके, फेरि अर्को एउटा प्रोभर्ब यहाँ लाग्यो है, तस्बिर आफै बोल्छ. The picture speaks for itself, or the diagram speaks for itself. त्यो कहाँ लगाइएको होला हैन, तर यहाँ पनि अप्लाई भयो. The light chapter is getting more and more interesting, isn't it? Okay, anyway, यो भयो तिम्रो थर्ड रिजनिङ. अब हाम्रो फोर्थ रिजनिङ आउट. Stars appear to twinkle but actually they burn continuously. अब स्टार किन ट्विंकल हुन्छ त? यसको लागि पहिला डायग्राममा बुझौं है. once again डायग्राम इज इम्पोर्टेन्ट. डायग्राममा बुझौं अनि त्यसपछि मात्र यो गिभ रिजन तिर आम है त. ल यो डायग्राम हेर त. This is earth, and this is atmosphere, this is space. Yes, here we have a star. And you know that space is rarer medium and the atmosphere or air in atmosphere is denser medium. Okay, space is rarer medium, atmosphere is denser medium. And in atmosphere also, the upper layer of atmosphere has low density than lower layer of atmosphere. The air has highest density near the ground. So in atmosphere also there is gradual layering. Okay, I haven't shown that gradual layering in atmosphere. It would make the diagram complex. Okay, that's why I've shown only one layer, that is space versus atmosphere. Okay, so this is the star. Yes, the star is actually here. This is the light rays coming from star. Okay, when the light rays of star enters the atmosphere of Earth, it bends because the light rays traveling from rarer medium to denser medium. And you know, when light rays travel from rarer medium to denser medium, it bends toward normal. So just follow the black line. See this black line, follow it. Okay, see the light ray is traveling like this, isn't it? Now you can see it. This is the path of light ray. Understood? So the light ray, after bending the light ray, it reaches here. Yes, and you know that after refraction your brain does not produce the image where it actually is, because our brain cannot manipulate this kind of, or our brain cannot calculate the refraction of light, the bending of light. Our brain simply sees the star wherever this line traces back to. Okay, this black line, you can see the black dot. Can you or not? You can see the black dot. Okay, this black line, black refracted line, traces back to this point. So you will see the star here. The star is actually here, but you will see it here. Here is a star. You will see it here, but the star is actually here. Understand? That is because of the refraction of light at the surface of atmosphere, at the boundary of atmosphere. Understood? However, due to continuous wind forming in the atmosphere, the density of atmosphere does not remain the same. It keeps on changing at different layer. That means the refractive index of atmosphere keeps on changing. Every moment its refractive index is different. What does it mean? It means every moment the extent of bending of light keeps on changing. Okay, one moment the light is bent, tracing the black path, yes, black arrow. Another moment the light might be tracing the red arrow. Okay, one moment the light is passing through this black arrow. Another moment the bending of light increases, refractive index increases, bending of light increases, and the light traces or light bends through red arrow. Or the refractive index might even decrease. If it decreases, then the light ray would pass like this, isn't it? Understood? So when light ray, let's discuss about this red path. When light ray traces the path of red arrow, then what our brain sees is, our brain back traces this light ray. See the red dotted line? Yes, the red dotted line, you can see it, isn't it? So it traces it back to at this point. So at that moment star appears to be here. Understood? So at one moment star appears to be here, another moment it appears to be here, and next moment star appears to be here, and next moment it appears here. So at different moment, at each and every moment, you will see the star at different point. Okay, and when you see things at different point, then it creates the twinkling effect. Understood? Okay, when you see the same object at different point at each passing moment, then it creates a twinkling effect. That's how the star twinkles. Okay, so here also, what is the cause of twinkling of star? It is refraction. Had there been no refraction of light, then there would not be twinkling of star. Okay, now see the note. Now I guess you would understand it now. Stars appear to twinkle, but actually they burn continuously because of refraction of light. Density of air is very low at the upper layer of atmosphere. It is highest at the ground layer. So upper layer of air acts as rare medium and lower layer of air acts as denser medium. So light coming from star has to pass through rarer to denser medium, which makes it bend toward normal. Hence a star is seen at a virtual speed. You understand what is the virtual spot means? Virtual means you will see at the spot where it is not there. Okay, next paragraph. However, due to the continuous wind being formed in atmosphere, density of different layers of air keeps on changing. So the refractive index of the atmosphere does not remain constant, and different degree of refraction occurs every moment. So the virtual spot of the star changes every moment. See this point? The virtual spot of star changes every moment. Sorry. Got it? This is the reason. Yes. Okay. When we see continuously changing spot of star, we see it as twinkling of star, and that is why if you are in space, you do not see the stars twinkling. If you see it from space, then the stars burn continuously. Okay. Well, that's it for today. That's all for today's class. In our tomorrow's class, in our next class, we will discuss about another feature, total internal reflection. Okay, it is better if you prepare on that topic in advance. Okay, until then, thank you class. See you in our next class.